Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. 12,900 years ago, an asteroid or a comet impacted the Laurentide ice sheet that covered North America. The impact triggered the Younger Dryas global cooling event and caused the extinction of many species of megafauna and the Clovis people. Since an extraterrestrial impact on ice does not leave the same traces as an impact on land, many scientists doubted the hypothesis of the Younger Dryas impact. But there is now sufficient evidence to prove that the impact occurred. This presentation explores the effect that the extraterrestrial impact had on the Earth's atmosphere. An extraterrestrial impact has many atmospheric interactions. First, there is the passage of the asteroid or comet through the atmosphere. Then, there is the excavation of the crater and ballistic ejection of debris, the expansion of the conical ejecta curtain, the re-entry of the ejecta through the atmosphere, and surface winds during the secondary impacts. Finally, there are long-term climate changes after a large extraterrestrial impact. The Earth's atmosphere has a thickness of 100 kilometers, and it affects the passage of extraterrestrial objects. Atmospheric drag and gravity in the presence of ablation interact to slow down a constantly shrinking projectile and make its angle of impact more perpendicular to the surface. A trajectory tangential to the Earth's surface would take a meteorite approximately 1,100 kilometers through the atmosphere. This distance would be traversed in 65 seconds by an asteroid with a speed of 17 kilometers per second, and a comet with a speed of 50 kilometers per second would cover the same distance in 22 seconds. The meteor over Chelyabinsk, Russia in 2013 provided an example of the atmospheric effect on a small asteroid moving at 19 kilometers per second. A large asteroid or comet would radiate intensely, start fires, and send powerful shock waves to the surface during its passage through the atmosphere. The debris ejected from an impact crater follows ballistic trajectories from its launch position within the crater. When the crater is excavated, the innermost ejecta are launched first and travel fastest, following the steepest trajectories. Ejecta originating further from the center are launched later and move more slowly, falling nearer the crater rim. Because of the relationship between the position, time, and velocity of the ejection, the debris forms an ejecta curtain in the shape of an inverted cone that sweeps outward across the target. The extraterrestrial impact on the ice sheet at Saginaw Bay ejected pieces of glacier ice in suborbital ballistic trajectories. The excavation of the ice sheet and the ejection of glacier ice pieces lasted approximately 30 seconds. The first pieces of ice ejected had speeds of 4 kilometers per second and reached heights of 370 kilometers, well above the Earth's 100-kilometer thick atmosphere. Pieces of ice ejected later had speeds of 3 kilometers per second and reached heights of 150 kilometers above the Earth's surface. The slower ice boulders traveled for 6 minutes before hitting the surface. Ice boulders with greater speed and a higher trajectory had flight times of about 9 minutes. All the ice bombardment happened within 10 minutes. In the aftermath of the Younger Dryas extraterrestrial impact, a layer of glacier ice from the secondary impacts covered the eastern United States. The saturation bombardment by the glacier ice boulders killed megafauna and Clovis people within a 1,500-kilometer radius from Saginaw Bay, all the way from the Rocky Mountains to the east coast of the United States. The ice bombardment left a layer of glacier ice half a meter deep. The onset of a global winter lasting 1,300 years made matters worse and contributed to the extinction of species that had survived through the last glacial maximum 26,500 years ago. In addition to the ejection of glacier ice boulders in ballistic trajectories, the extraterrestrial impact had two major atmospheric effects. The first one was the expansion of a vapor plume of steam produced by the high heat of the impact on the Laurentide ice sheet. The great pressure of the steam increased the speed of the ejecta and broadened the shape of the conical ejecta curtain. The second atmospheric effect of the extraterrestrial impact was to shift the polar jet stream southward from the impact point and to lower the fast-moving band of air toward the surface from its normal altitude of 10 to 14 kilometers. Water ejected above the atmosphere produced clouds of ice crystals in the vacuum of space. As the vapor plume and the ejecta curtain expanded, they pushed the polar jet stream southward and trapped it under the ejecta curtain. Chunks of ice as big as a baseball stadium plunged to Earth at 11 times the speed of sound with energy of 3 megatons of TNT. Atmospheric ablation of the ice boulders produced vapor trails that blackened the sky. The impacts produced shock waves that liquefied on consolidated soil. The ice boulders formed inclined conical cavities hundreds of meters wide that quickly transformed into shallow elliptical bays on the trembling liquefied soil. The secondary impacts of glacier ice ejected by the extraterrestrial impact liquefied the ground and produced inclined conical cavities. The prototypical elliptical geometry of the Carolina Bays corresponds to cones inclined at 35 degrees, and it is the most convincing evidence that the bays were created by impacts and not by wind and water mechanisms. The major axes of Carolina Bays and the Nebraska rainwater basins have radial alignments that converge at Saginaw Bay, which was the site of the extraterrestrial impact. Glacier ice boulders that fell on rivers created splash chevrons that overlaid some bays. The chevrons are only on the east banks of the rivers because the splashes were blown by the strong wind of the jet stream that had been brought close to the surface by the collapsing ejecta curtain. Kelly Bay in South Carolina demonstrates the sequence of emplacement during a brief period of saturation bombardment by glacier ice boulders from 6 to 9 minutes after the extraterrestrial impact. First, Kelly Bay was created along the river by an impact of glacier ice. Second, impacts of glacier ice on the Little Pee River created splash chevrons that overlaid Kelly Bay. And third, the chevrons were impacted by glacier ice boulders with higher trajectories and longer flight times that made small bays on top of the chevrons. The Younger Dryas extraterrestrial impact produced microspherules from the Earth and from the impacting body that were widely distributed by the prevailing winds across 50 million square kilometers throughout North America, South America, Europe, and the Middle East. In the aftermath of the extraterrestrial impact, the land was shrouded in darkness by thick clouds, smoke, and the ice crystals in low Earth orbit that blocked the light of the sun. The sandy soil close to the water table was covered with elliptical Carolina bays, and hard ground was covered by half a meter of ice from the ballistic hailstorm. The global winter of the Younger Dryas started with a great snowfall from the condensation of steam produced by the extraterrestrial impact on the Laurentide ice sheet and by condensation of the vapor trails produced by ablation of glacier ice boulders during their re-entry from their suborbital space flights. Very cold weather prevailed for 1,300 years. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.